Okay, turn to page 51 in your notes. Today we're going to go over how to write and graph exponential decay functions. Last class we went over exponential growth. Now we're going to go over exponential decay. So, if you look at page 51, it gives you the definition of exponential decay. Now, the big difference between an exponential decay function and an exponential growth function is, in both cases, A has to be positive, because if A is not positive, it's not considered growth or decay. Now, B, to be growth, B was greater than 1, right? But now, for decay, B is in between 0 and 1. And the reason this will be decay is because when I raise a fraction, which is in between 0 and 1, to a power, what happens to it? 1/2 squared is 1/4. 1/2 cubed is 1/8. The bigger x gets, the smaller y gets. And if we use a negative exponent, 1/2 to the -1, that means we do 1 to the -1 over 2 to the -1. We move 2 up top, 1 on the bottom. It gets bigger. So when a fraction is raised to a negative exponent, it gets bigger and bigger and bigger. When it's raised to a number that gets, when x gets bigger, y gets smaller. When x gets smaller, y gets bigger. As a result, the more negative it gets, the higher this goes. The more positive it gets, the closer and closer and closer it reaches 0, but it never actually reaches 0. It just gets closer and closer and closer to 0. Because 1/2 to the 10th power is going to be 1 over, shouldn't have picked 10th. It's going to be, let's say, 516, but it's not going to be that. I don't know what 2 to the 10th is, but the denominator keeps getting bigger and bigger and bigger and bigger, but it's never going to actually become 0 or go into the negatives. So, where a growth function will look like this, because as x gets bigger, y gets bigger, a decay function will start big when x is negative and get smaller when x gets more and more positive. So this is growth and this is decay. Now, we don't call them growth and decay when they reflect, but this is the reflection of growth and this is the reflection of decay. So you can reflect an exponential function, it's just not called decay or growth, and that's when A is negative. Okay, so let's look at page 51, and we're going to graph y equals 1/3 to the x. Now notice, I have to put the entire fraction in parentheses if I want the fraction raised to the x. So 1/3 to the x is really 1 to the x over 3, so be careful that you put that in parentheses. Now, we make a table. -2, -1, 0, 1, and 2. 1/3 to the -2 means I do 1 to the -2 over 3 to the -2, which is really 3 squared over 1. So that becomes 9. So 1/3 to the -2 is 9. 1/3 to the -1 means flip it, it's 3. Anything to the 0 is 1. 1/3 to the 1 is 1/3. 1/3 squared is 1/9. So now, when we graph this, so at -2, it's going to be way up here at 9. -1, 3, 0, 1, and then these get very close but never actually hit 0. And that's what it looks like when you graph it. Okay? So it says draw a smooth curve through the points from either the table or the graph. You can see that the range is all positive numbers. So if I was going to write the range, y is greater than, not equal to, y is greater than 0 would be the range. Okay, let's turn to page 52. Now, on page 52, what we're going to do is we are going to compare these two graphs. Y equals 2 times 1/3 to the x, and we're going to compare that with y equals 1/3 to the x. Okay? So, here you have a chart. It's vertical instead of horizontal. When we just did y equals 1/3 to the x, and this is y equals 2 times 1/3 to the x. So this is going to be a stretch because a is greater than 1. So here we'll copy the values we had before, 9, 3, 1, 1/3, 1/9. Now I'm just going to multiply those by 2. So I have 18, 6, 2, 2/3, and 2/9. So when you graph both of these together, 1 is going to be like this. So the stretch is 2 times, so because the y values are 2 times the corresponding y values, the graph is a vertical stretch. So now I want everyone to do checkpoint on your own, and you're going to be graphing y equals -2 times 1/3 x. So obviously that's going to be a reflection. Because it's a reflection of a decay, we don't call it decay anymore. It's only decay if a is positive. So go ahead and do the checkpoint, stop the video, and turn it back on when you're done to see if you got it right. And here is a picture of the vertical stretch with reflection. Okay, now let's turn to page 53. Example 3 says, tell whether the graph represents exponential growth or exponential decay. Then write a rule. Well, since when x values get smaller, the y values get larger, we know this is decay. So we know this graph is exponential decay. But we have to come up with the rule. Now, the only information they give us is they give us 2 points. They give us 0, 5, and they give us 1, 1. So, there are different ways we can approach this. Okay? Now, we know the y-intercept is 5 because it's 0, 5. So a equals 5 because we know a is the y-intercept. And then it says find the value of b by using the point 1, 1, and a equals 5. So basically we know this is a equals 5. We know a equals 5 because this is the y-intercept. So we know y equals ab to the x. So if y equals 5 times b to the x, we now plug in x and y and solve for b. So 1 equals 5 times b to the first. So 1 equals 5b. Divide by 5, divide by 5. We get b equals 1/5. So y equals 5 times 1/5 to the x. And that would be our rule. Okay? Now, there's another way you can solve this. You could also say, okay, I'm going to make an xy chart. I know when x is 0, y is 5. I know when x is 1, y is 1. okay? X is increasing by 1. And what am I multiplying 5 by to turn it into 1? I'm multiplying it by 1/5. So I know that B is my multiplier. I know that A is my y-intercept. So by doing my little chart, I know this is 5 times 1/5 to the x. So that's another way to do it. Okay, now, if we look on page 53 in the margin, I have copied problems 38 and 40 for you from page 536. I want you to stop the video and try to do 38 and 40 on your own. And after you do them on your own, turn the video back on and see if you're right. Okay, so 38, they tell us here's 2 points, 0, 6, and 1, 4.8. Now, 2 different ways to do this. One way is we can make up a little chart. 0, 6, 1, 4.8. Okay, so what do I multiply 6 by to turn it into 4.8? Well, all I have to do is put 4.8 over 6, and that's 48 over 60, and that's 4/5. So I could either write 4/5 or I could write a 0.8. But I know that B equals 4/5. I know that A is my y-intercept, so it's the value when x is 0, y is A. So if A equals 6 and B equals 4/5, then I know my rule is y equals 6 times 4/5 to the x. Okay, that's 38. Now let's look at 40. So 40, they give you 1 and 12.8 and 0 and 8. Now, when x is 0, A is the y-intercept, so A equals 8. So I can either set up a chart, 0, 8, 1, 12.8. I can say y equals 8 times b to the x, and I can make this x and this y. I can say 12.8 equals 8 times b to the first, and I can divide 12.8 by 8, so b equals 128 over 80. And 8 goes into 12 once, 8 goes into 48. 16 over 10, which is 8 over 5. So I get b is 8 over 5. So the answer would be y equals 8 times 8/5 to the x. Okay? Now, the other way I could have done it is I know what A is, and I can figure out B here by doing 12.8 over 8, which we said became 8/5. So either way you do it, it's 8 times 8/5 to the x. Okay, now, there's one more that I want you to try, and this one is a little harder, and it's at the bottom. It's a little harder because they do not give you the y-intercept, do they? So they don't, we don't know what A is. But what we can do for this is we can set up a chart. So x, y, -2, 2/9, -1 2/3. Two things you can do. You can try to extend the pattern to 0. And if you extend the pattern to 0, you'll know what A is. So this is going up by 1 by 1 by 1. And what's happening to the 2/9? Well, if I multiply 2/9 by 3, I get 2/3. Or another way of figuring that out is you take 2/3 divided by 2/9. 2/3 divided by 2/9 is the same as 2/3 times 9/2. Cross that out and you get 3. So I know my multiplier is 3. So I know B equals 3. Now if I multiply 2/3 times 3, I get 2. So I know that A equals 2 and B equals 3. So I know my rule is 2 times 3 to the x. Now another way of doing this is by saying that I know you figure out what you have to do to 2/9 to get 2/3, and I multiply by 3. And once you know B is 3, you can plug in and solve for A. So I know y equals A times 3 to the x. So I'm going to use these 2 points, and I can say 2/3 equals A times 3 to the -1. So 2/3 equals 1/3 A. And if I divide this by 1/3 and this by 1/3, A equals 2. So you can always, once you know A or B, you can always plug a point back in to find the missing one. Okay, now, the other thing I want you to pay attention to is I tell you, you have to know this for the test. You have to know exponential growth is when B is greater than 1. Exponential decay is when B is in between 0 and 1. And in both cases, A has to be greater than 0. So it's neither the growth or decay when A is less than 0. So reflections are not called growth or decay. They're just called exponential functions. Okay? Now, you're also going to have to know the exponential decay model and the exponential growth model. And we will go over that on the next video because we're going to go over word problems on the next video.